Okay, we can look at geometric sequences and series here. Geometric sequence is a sequence of non-zero numbers, where we get each term in the sequence by multiplying the previous term by a fixed number. So we start with an arbitrary number, in this case a sub 0, and we keep multiplying that number by a common ratio r. So multiplied by the same number, you get a sub 0 times r for the second term, or sub 0 times r squared for the third term, and so on. So here are some examples: 2, 8, 32, and 128. Each term is multiplied by a 4. So our common ratio is 4. We can see that by taking each term and dividing it by the previous term. 8 divided by 2 is 4. 32 divided by 8 is 4. 128 divided by 32 is 4. Here is another example where the terms actually get smaller, and we can see what the common ratio is again by dividing each term by the previous term. 12 divided by 24 is a half. 6 divided by 12 is 1/2, and so on. So the common ratio is 1/2. And use a third example where our terms just alternate in sign: 3, -3, 3, -3, and so on. And in this case, the common ratio is -1. Generally, we can write the terms of a geometric sequence using this formula. So the nth term, a sub n, could be found by taking the very first term, a sub 0, and multiplying it by r to the n minus 1. Right, so notice the power is 1 less than the term we're looking at. So for the third term, we would multiplying it by r squared, because the very first term we start with isn't multiplied by anything. Right, so if we again look at the sequence we had earlier, 2, 8, 32, and 128, we can write that as a general term: 2 times 4 to the n minus 1. And if I want to find the third term, I can just take 2 times 4 to the 3 minus 1. That would be 2 times 4 squared, or 2 times 16, and that gives me 32. As we can see, the third term is 32. A geometric series is the sum of all the numbers in a geometric progression. Right, so if I just want to add some of those terms, this is the formula we would use. The sum of the first k terms of a geometric sequence can be found by using this formula. We take a sub 0, which is our first term, multiplying it by 1 minus r to the k, and then dividing it by r minus 1 minus r. Or this is usually the notation we use if we're adding. So recall, sigma means we're going to add things starting with n equals 1 all the way to k, and that will give us the sum of the first k terms. So as an example, if we go back to the sequence we had, and let's say we want to add the first 4 terms using the formula we just saw, the sum of the first 4 terms would be 2 times 1 minus 4 to the 4th over 1 minus 4. 4 to the 4th is 256. So on the top I have 2 times 1 minus 256. On the bottom is -3. And that gives me -510 divided by -3, which is 170. And we can see if we had added the first 4 terms, 2 plus 8 plus 32 plus 128, would have given us 170. An infinite geometric series would be what we would get if we kept adding all the terms in the geometric sequence. So we don't stop after the 4th term, we keep adding all the terms. And here's an example of the sequence we were looking at earlier: 2, 8, 32, 128. And if I keep adding the remaining terms, 512, 2048, on and on, we clearly see that this series will diverge. That means it doesn't give us a finite answer because the terms keep getting bigger. It turns out that for a geometric series, as long as the terms keep getting smaller, we will actually get a finite answer. So if and only if the absolute value of the common ratio is less than 1, that means my terms keep getting smaller. They could alternate, so R could be negative, but its absolute value of it has to be smaller than 1. We could actually get a finite sum for all infinite terms of a geometric series. And that could be found using this formula a sub 0, which is our first term, divided by 1 minus R. Or again, if we use the sigma notation, if I add all the terms from n equals 1 all the way to infinity of a geometric series, we use the formula we just introduced. So if we go back and look at the second series we had seen earlier, 24, 12, 6, 3, and on. The first term is 24. The common ratio is 1/2. Absolute value of 1/2 is less than 1. So this series would converge. And if I use the formula we just saw, 24 over 1 minus 1/2, that would be 24 over 1/2. And 24 times 2, if I multiply by the reciprocal, gives me 48. So the sum of that infinite series would be 48.